So we'll start out with, are there any questions?
Yeah, I have a question, so, it's on one of the, practice, well, not practice tests, but past tests. Yeah, so, it is. Yeah, so. it's
Just-
six-
Okay, yes?
Yeah, so it's mock test 1B, spring 2019.
I'm gonna have to see the problem.
Yeah, it's basically this.
The direction of the forces? It's similar to the
Yeah, the master set.
master set. Rejected. Since that was off camera, I nailed the target. I threw the marker into the basket. Perfect. I'll pick that up at some point. So we have the two blocks situated like that. The top block is being pulled. The force diagram to start out with. And then we have our checklist here. I guess we now have springs. All right, so what forces are involved?
So you have friction, for the top block, that's acting left, cause it's gotta be opposite.
Okay.
And then you have friction on the bottom block going right.
Okay, because the Newton's third law.
And you have a normal force, acting up on one. And, that same force going down on two.
Right.
You have weight acting down on both.
And then up on the ground.
Yeah. I think that's it.
All right, so we have the gravitational force done. There are no springs. You did one pair of normal forces. Oops, it's labeled. There's one pair of normal
Oh,
forces.
yeah, a normal force going up on two. And down on the ground.
Only two. All right, so I got the two objects there. Normal force done.
And then, and you have an other force going right, so.
Yep. So others done. There's no ropes. And in that particular problem, I can't remember what I said about friction down here, but we can assume that there's friction just to start with, and then get rid of it later if we have to. But which way is mass two gonna move?
So.
Or which way would mass two want to move?
I'm not really sure. Wait, right?
With mass one.
Yep. So therefore, common pair frictions like that. Yes, Brooke?
Is SR elastic force? Because
Yes,
S sounds-
yes.
okay.
S for spring.
Right.
Or S for elastic, and the S is silent.
So, for, when it says friction that M2 exerts on M1, then that would be left.
Did it say friction force, normal force, or just force?
It said friction that M2 exerts,
On M1, that's this one right here.
yeah. So like, which friction would we, I mean, I think, so wouldn't it be, right? Since the pair that, so M1 has, friction that's going left, so M2 has the friction that's going right. For the,
These are the forces that are acting on that object. So this is the force acting on mass one, that's the force acting on mass two. I might have misheard or my brain just processed it wrong, but I thought it was the force that mass two exerts on, the friction force that mass two exerts on mass one.
Yeah, so which force is,
This is you draw the arrow on the object that's experiencing the force. This is the force on mass one, so we draw the arrow on mass one.
so that means that M2 is exerting that force on M1, right? Like, so that arrow that's going left for friction, so M2 is causing that?
Yes.
Oh, okay, that makes sense now.
Okay.
I thought that M1 just like has that force. I didn't know that that's because of M2, but that makes sense with me.
Yeah, when you're drawing the pair, I mean, this is the force that two exerts on one, and that's the force that one exerts on two.
Oh,
I mean, the force is there because of both objects.
okay. Yeah, that was basically the only one that I had.
Okay. Alright, so questions on stuff not related to the test. I can stay afterwards if you want to,
Okay.
for questions about the test. Harrison, what's the answer?
The answer is, I wasn't sure if we were gonna have class today, but we did, so I'm glad I came, because the parking lot was empty.
How did you know what the question was? There we go. Alright, so why don't we pick up where we left off then? I believe we were dealing with collisions,
Yes.
and this was, what was the mass of this one? That's going to the right?
Three, and it has an acceleration of, no, velocity of 4 meters per second.
Right? And-
Uh, Wait, I'm sorry, this is the one that we said the final velocity is 0, because it's like, this was 3 times 4 and this one was 2 times 6, but you
Okay.
changed it.
Yeah, so we changed it to 6 and 5 meters per second.
Yeah, the second one.
No, for the second one. it's
Second
6.
one, 6 kilograms, 5 meters per second. That was 3 kilograms, 4 meters per second.
Yes.
Alright, we set up the equations, we didn't actually solve it, is that right?
It looks like we solved it for perfectly inelastic. But I think we-
No, perfectly elastic, we didn't solve the perfectly elastic collision,
Mm.
my recollection.
Oh, right, we didn't finish it. We finished the perfectly inelastic, but we didn't finish the perfectly.
Alright, so we're doing the perfectly elastic collision, which I'll sometimes just abbreviate as PEC. First off, collision, should be thinking conservation of momentum, especially since I haven't introduced any outside object besides these two, it's a closed system. And elastic collision, perfectly elastic collision, kinetic energy is conserved. And so if we assume that to the right is positive, we have 3 times 4 plus 5 times 6 is equal to 3 V3 final plus 6 V6 final. And then I said, let's use the abbreviation of C is equal to V3 final and D equal to V6 final. We ran into the issue of I was using D for 2 different things here. It won't be the last time, and the other ones won't be by accident. It'll just be a preview of Physics 152. This is legitimate in physics. These 2 V's mean 2 different things. Electric potential and volts. And there is a mistake on the board in that first equation. What is the mistake?
Is there a squared?
No, not squared.
Oh, no.
The notation,
Pardon?
the notation, like you didn't put initial on the left side?
Oh, no, not a notational thing. It's actually more,
Is it minus?
yeah. -5. We're dealing with velocities here. This is momentum. Momentum is mass times velocity. And so direction matters. The fact that the 5 is going to the left, when I said to the right is positive, means that that is a -5 there. So again, 12 minus 30 is equal to 3c plus 6d. -18. 3c plus 6d. So this is my momentum equation right here. That T initial is equal to T final. And that should match what we had last time. Or does it?
I don't know why in my notes I have like these equations.
So we're about to do that one.
Oh,
Okay.
Gotcha.
So this is the collision aspect of it. If we were dealing with a perfectly inelastic collision, C and D are the same value because they're sticking together. However, they're not, so these are not the same. The second equation is the perfectly elastic piece of it, the fact that K initial equals K final. And now we get to the squares, because as we all know, the formula for kinetic energy is,
1/2
mv squared.
that was nice. So I have 1/2 m1 v1 squared plus 1/2 m2 v2 squared initial is equal to 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Generically, two objects. Kinetic energy I have at the beginning equals the kinetic energy I have at the end. And typically for these type problems, when the two objects collide, they're not in contact for an incredible amount of time. There's not enough for position to change significantly for potential energy really to have much of an influence here. So we are ignoring that. Also, if we had some additional force acting on it that would cause a change in potential energy, more specifically, if we had some outside conservative force acting on it, causing a change in potential energy, then it's now an open system. So I have 1/2 times 3 times 4 squared plus 1/2 times 6 times 5 squared equals 1/2 times 3 times c squared plus 1/2 times 6 times d squared. And so this is 24 plus 75
Yeah.
equal to 1.5 c squared plus 3d squared. And that's sort of where we left the cliffhanger last time. It's now a math problem. So first thing I'm gonna do is over there, if it happens to work this time, I'm gonna divide everything by 3, just because they're all multiples, all the coefficients are multiples of 3. And so I have -6 is equal to c plus 2d. For this one right here, just add it together to get 99. And I can divide everything by 1.5, that also works out. That's nice. So I get 66 equals c squared plus 2d squared. Yeah, I feel comfortable with that. Two equations, two unknowns. How do I solve it? Or how do we solve it?
solve for one variable, plug it into the other one.
Alright, what do you wanna solve for?
C.
Okay, that seems easy, cause nothing has to be done other than just moving the two D over.
Right.
So C is equal to negative two D minus six. And then Jacob?
And then plug it into the other equation.
Did you take the square root of 66? Is that how you got this negative 6?
What's that again? How did I get the negative six here?
No, how did you, so you went from c squared plus 2d squared, and now you subtracted the 2d over, but there's no square.
About just from this equation, there's no squared in that first equation, it's the minimum equation.
Okay, sorry.
We're now about to plug into the squared, so we're gonna end up squaring this. I feel like I'm missing the question, or,
I was just confused how you got from 66 is equal to c squared plus 2d squared.
oh, to this, I didn't. I went from here to here.
Oh, okay, okay. Oh, yeah, you drew an arrow from, okay, makes sense now.
Alright, you good?
Yes.
Alright. So now I have 66 equals negative two D minus six squared plus two D squared. And so 66 is equal to four D squared plus
Um,
24D plus 36. So good with the 4D squared to 36, so 6 times 2 is 12, times 2 is 20, okay. I'm feeling somewhat confident. All right, that dramatic pause was for questions if you had any. So 66 is equal to, well, actually, it's a quadratic here. I have two quadratic terms, but I'm just about to combine them. And so, ultimately, I'm gonna be plugging into the quadratic formula, unless you just have to get lucky here and it can be factored without that, but I am going to get everything on the right-hand side. 0 equals, so I have 4D squared and 2D squared, 6D squared, plus 24D. And then I have 36 here, and I'm going to subtract 66, so minus 30.
Can you just divide everything by 6?
That sounds good to me, so I get D squared plus 4D minus 5. And that actually can be factored. Or quadratic formula fans. You wanna use quadratic formula or just factor?
Let's just factor.
So I got D and D. So I wanna multiply them together to get negative 5, which would be 5 times 1. And I want the middle term to be positive, so it's plus 5 minus 1. That feels right. And so if D minus 1 times D plus 5 equals 0, what does D equal?
Wait, why is it equal to 0? Oh, is it 1 or negative 5? Yeah.
It is indeed 1 or negative 5. Now, if that's the value of D, then I have a formula right here for C. If I plug in 1 in for D here, negative 8. This is meters per second, meters per second, meters per second. If I plug in negative 5,
You get 4.
so my answer is either this or this.
Do we know based on, like, the direction that we know it's going in? Like, how do we figure out which one it is?
Let's see if anyone else notices what one of those solutions. There was a solution we're going to reject might appear to some of you as to why. Awkwardly worded, but there it is.
This is after the collision, right? Like
Yes, it is.
velocity Final. So, and this is perfectly elastic.
Yes,
It should be the top one then, right?
why?
Because they bounce in opposite direction.
They're not, I can set up a perfectly elastic collision where they end up going in the same direction afterwards.
No, it should be the, oh wait, that's C, never mind. Wait,
Well, but both sets of answers are different sign. So they're going to be going different directions in the end, no matter what.
Yeah, but one of them automatically, looking for the general concept here, one of these automatically we know is not true. Because as Brooke established, this is after the collision. Excuse me.
wait, which one is C? C is, okay.
C is the
Velocity
3 kilogram
theory.
mass.
So, it should be the top one,
Why is it not the other one?
because, well, we can, well, I don't know, you said that they could go in the same direction, but assuming they like bounced off of each other, then the 3 kilogram mass would be going this way, and we established that the positive direction was to the right,
Correct.
so we know that that one's true. Am I like halfway there?
You're missing something that I'm hoping people will see. Alright, so the first one is the correct answer. The second one is the part that actually tells us, I know we did it right, unless we screwed up this part, but this, I was expecting this as one of my answers.
Are they too, like, close together, like the speeds?
No,
What's the
that's not the issue.
They're the
Pardon?
starting speeds.
Say it again?
They're the starting speeds.
Yes. We were looking for a situation where we had the exact same moment as them and the exact same kinetic energy. Well, one of the solutions better be exactly what it is before they collide. The 6 kilogram mass is going -5 meters per second to start with. The 3 kilogram mass is going 4 meters per second.
Okay. Wait, but how do we get that from what we solved for?
We solve for